Eric Burgess here. How many ways can 4 students be selected from a class of 12 if they all are given the same job? What if they are given different jobs? Alright, so here we know we're picking 4 students from 12, and there's a bunch of ways we can do this, right? So if we were to have like 4 spots, here's spot 1, spot 2, spot 3, spot 4. Let's say that we pick student 1, then student 2, then student 3, then student 4. Right, student 1 would have the same job as student 4. So let's say that we picked them in a different order. So the same people got picked again, but this time it was 4, 2, 1, 3. So a different order, but in this case we see they all still get the same job. Nothing different happens as a result of picking them with a different order. So what this means is that order does not matter. This is not a unique string of numbers. The students, the order they're picked in, doesn't matter because they're all going to get the same job. So in that case, we know to pick combinations. So the formula for combinations, again, this is for part A, is NCR. And recall that that is equal to n factorial over, and now it's like permutations, it's n minus r factorial, except for we take out a few extra things because there are less sets of numbers that'll work because it considers things like ABC to be the same as CBA. Like these are not different. So there's going to be less combinations. And so that's why we divide out by an extra factor of factorial r. So we can go ahead and just do this. So n is the total number of things. So in this case, it's people. And there's 12 people total. And we're choosing 4 of them. And if we plug this into our formula, we have 12 factorial over 12 minus 4 factorial, 4 factorial, right? Because this is r and r again. Just plug it in exactly how it looks in the formula. And now dealing with this, we could say, well, okay, this is the same thing as 12 factorial over 12 minus 4 is 8 factorial times 4 factorial. In fact, I can even make this fraction a bit smaller. So 12 factorial, that's equal to 12 times 11 times 10 times 9 times 8. And if we stop at 8, we'd keep going. It's the same thing as 8 factorial over 8 factorial. And then 4 factorial, let's write that one out. 4 times 3 times 2 times 1. So here we could see the 8s will simplify to 1. This 4 can simplify with this 12, right? This becomes a 3, this becomes a 1. This 3 can simplify with that 3. This becomes a 1, and this becomes a 1. This 2 can simplify with this 10. And so we're left with just 11 times 5 times 9. Because on the bottom is 1, and anything divided by 1 is itself. So doing this, we get 11 times 5 times 9. And we get 495 ways. Now we can, of course, do this with the calculator. So first we type in n, because it comes before. So we're going to type 12. Then we're going to go to math, go over to probability, and choose NCR. It's option 3. We're going to hit enter. And now we type in the R number on the R side, which is 4. We hit enter, and we see we get the exact same result, 495. So if you use the calculator, that's how you would do that. Now for the second part, B, they're not labeled A, B, but I'm going to label them that. What if they are given different jobs? All right, different jobs means that, you know, maybe the first person sweeps, second person, I don't know, cleans the bathroom. You wouldn't want that job, right? Wouldn't want to be picked number 2. So let's see here, 1, 2, 3, 4, 1, 2, 3, 4. So let's say we had the students, student 5, 7, 9, and 10 were picked. Well, if we pick the same students but in a different order, maybe 10 and 5 swap places, this would be different, right? Because the last person would get a different job. So maybe if they're picked last, the bathroom is their job, they're the worst one. And the other person, the person's front, they're the supervisor. So you really want to be picked first, right? It really makes a big difference. So here we can see order matters. Since order matters, we're going to use permutations. So that's NPR. And the formula for that's just like R, but since there's more possibilities, we don't divide out as much stuff. So it's just N minus R factorial. So this is going to be the same thing as 12 permutate 4, right? They're still picking 4 people. So this is equal to 12 factorial over 12 minus 4 parentheses factorial. Parentheses are really important. It's a common mistake I see, by the way, so just be sure to include the parentheses. If you don't, the factorial will get you all messed up. So again, we're going to simplify the 12 down to 8. So 12, 11, 10, 9, 8 factorial. And then underneath, we're just going to have 8 factorial, right? 12 minus 4 is 8, and then we have a factorial left. These will simplify out to 1, and you see we're actually going to get a bigger number. Let me move this equals to thing over here. It's going to throw us off. So this one's equal to 12 times 11. Whoops. Wow, that was exciting. Times 11 times 10 times 9, and we get 1,100, or what is that, 11,880 ways. There we go. And then if we use the calculator way, we would simply type 12, go to math, go to probability, and choose permutate, number 2. I'm doing that kind of fast because I've been doing a lot of these problems, but I trust you to be able to get to that menu. So we push it, we see we get the exact same thing. So this is a good way to check your work too. And some instructors want you to show the by hand work. This kind of reveals the choosing process. It's really just an extension of the counting rule, the fundamental rule of counting. But that is how you do this. If you've got any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.